Hello everyone. Today we will be discussing the problems of exercise 13.1 of chapter limits and derivatives. So first we will start with evaluating the given limits, and in these problems it is very simple, that is you are to just replace the value of x with the given limit value. Okay, that means the first question is limit x tends to 3 x plus 3, which will be equal to this limit x tends to 3 x plus 3 is same as you are just replacing the value of x with 3, so that you are getting it to be 6. That's all. That means we are just doing limit x tends to a f of x is equal to f of a. This simple way we are doing because it exists, right? Now here for the second problem, which is limit x tends to pi x minus 22 by 7 will be equal to, we are just replacing x with pi and you will get pi minus 22 by 7 as the answer. Now for the third one, which is limit r tends to 1 pi r square, again replacing r with 1, you will get it to be pi. It's as simple as that. Fourth one is limit x tends to 4x plus 3 by x minus 2. Here again you can just see if the denominator is replaced with, that is x is replaced with 4 in the denominator, it is not giving you any 0 in the denominator, so that you can just directly substitute the value. So you will get 4 into 4, replacing x with 4, plus 3 divided by 4 minus 2, which is 16 plus 3 divided by 2, or 19 by 2 is the answer. Now fifth one, in which you have limit x tends to minus 1 x raised to 10 plus x raised to 5 plus 1 divided by x minus 1. Here again you can just see that the denominator, if you replace with minus 1, it is not giving you 0 in the denominator, so that you can replace the value with what is given in the limit. So it is minus 1 raised to 10 plus minus 1 raised to 5 plus 1 divided by minus 1 minus 1. This will give you positive because it is odd power 1. Here it is, this is even power, it is 1, it is odd power, so it is minus 1, this is 1 divided by minus 2, so that you are getting minus 1 by 2 as the answer. Okay. Question number 6 is limit x tends to 0 x plus 1 the whole raised to 5 minus 1 whole divided by x. Now when you replace the value 0 to this numerator and denominator, what you are getting is 1 raised to 5, which is 1, 1 minus 1, 0, and in the denominator also 0. So it is of the form 0 by 0, right? So this is of the form 0 by 0. So what we need to do is we have to remove that form and then apply the whatever limit you have. So here it is not possible like this. Now we will just compare this to some power of x, no? So we can just see that if we have limit x tends to a x raised to n minus a raised to n divided by x minus a, then we have a property for that. So we will just make this question in that terms, where instead of x you have here x plus 1 and instead of n you have 5. That means, and a is 1, acting as 1, so 1 raised to the same power will give you the same value 1. Now the denominator should also be made in the same form. That means whatever is here should be here, whatever is here should be here. That means what I am writing is, again rewriting the question it as x plus 1 the whole raised to 5 minus, I can write it as 1 raised to 5 also, which is same 1, and denominator, which is x, can be written as, that is I am just adding and subtracting 1. Why? In order to make this and this included in the denominator. So if I am writing x plus 1 minus 1, there is no change, it is again x only, but I will just put a bracket here so that this will be exactly, or you can compare with that form. Okay. Now if you replace, again we need to check the limit. Here it is limit x tends to 0. But in this case, when they say limit should be x tends to a, that means whatever number you have here, x means this part should tend to that one, right? So here what we do is, we are just putting another variable as this, so as we have to change this limit. Okay, so this will be y is equal to x plus 1, suppose. So that when I say that x is tending to 0, then as x tends to 0, which is given in the question, what will happen to y? When x tends to 0, y will tend to 1. As x tends to 0, y tends to 1. That means we can replace the limit as well as the terms in terms of y. What will happen to the question? It will become limit y tends to 1. that is when you are taking y as x plus 1, as x tends to 0, y tends to 1. So the meaning is same. Again x plus 1 replaced with y, so it becomes y raised to 1 minus y raised to 5 minus 1 raised to 5 divided by, again this is y minus 1. Now you just go to through this one, okay, just compare. That means when it is in this form, the answer is n a raised to n minus 1. Okay, now you can again apply this result to this form, because it is in the form x raised to n minus a raised to n divided by x minus a, where limit x tends to a, right, y tends to 1. So this will give you n, which is 5, into a, instead of a you have 1, raised to n minus 1, 5 minus 1, which is equal to 5 into 1 raised to 4. Whatever be the power of 1, you will get it to be 1 only. So the answer is 5. Understood? Question number 7 is limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. Now again just see if it is possible to do in the direct method. That means just replacing with 2. This will give you how much? Here denominator will become 0 and numerator will become again 0. So you can say that this is in the 0 by 0 form if you replace it in the direct method. So that we need to do further things. In the earlier problem we used the formula based. Here again we can see that if it is possible to rationalize, that is any term which is making it as 0 by 0, if we are removing that term, then it is possible to do the problem. So first thing which we will say is this is of the form 0 by 0 if you replace in the direct form, right, direct method. Now we will just split the numerator, that is a middle term of the numerator, so that we can factorize it, write it as a factors of 2. So minus x can be written as minus 6 plus 5, that is minus 6x plus 5x minus 10, and denominator again you know that a square minus b square form, so it is x plus 2 into x minus 2. Now again this can be written as, that means from the first two terms you can take out 3x, so that this will become x minus 2 plus here 5 can be taken out, which is again x minus 2, giving you in the inside. Now you can just see x minus 2 is common to both the things, just take it out, x minus 2 into 3x plus 5. So these are the product of two factors which will give you this one, right? Now you can just see there is a common in the numerator as well as the denominator which can be cancelled. Now when you see whether it is possible to remove or put the value of x as 2, that is in the direct method, is it possible? Is it not giving you 0 by 0 form? If it is not giving, then you can just replace it. Now just see, here it is x plus 2. If it is 2, x is given that value 2, you will get 4 here. So that the numerator as well as the denominator is not giving you 0 by 0 form. Okay, so we can just replace the value. What you will get here, this is 3 into 2 plus 5 divided by 2 plus 2, which will give you 6 plus 5 divided by 4, or 11 by 4. Understood? So this is the third method, that is rationalization, factorization, factorizing the terms which you can and deleting the form, that is removing the form 0 by 0 and then doing the same direct method at last. Okay, so that is your rationalization method. So first thing which we did was direct method, next the direct application of the formula, standard formula, and this is the method in which you are using the factorization. Okay. Question number 8 is limit x tends to 3x raised to 4 minus 81 divided by 2x square minus 5x minus 3. So again if you replace 3 for this x, you will get it in the 0 by 0 form. So this is in the 0 by 0 form. That means we need to factorize and see whether again it is giving you the 0 by 0 form or not. Okay, so first we will just start with x raised to 4 minus 81 can be written as, this is actually, if you write x square as a square minus, this is again 9 square. And here in the denominator you can make it as 2x square, splitting the middle term minus 5x as minus 6x plus x minus 3. Again the numerator can be written as, this is a square minus b square, so it is a plus b into a minus b divided by, here 2x can be taken out, you will get x minus 3 plus x minus 3, so that this will give you limit x tends to 3. Again this can be split again further, so you will get x square plus 9 into x plus 3 into x minus 3. So x square minus 9 has been split and written like this. Again a plus b into a minus b, which is a square minus b square form. Now x minus 3 taken out and 2x plus 1 will be the remaining part. So again you can see that x minus 3 is in common with the numerator and denominator, that we can cancel. That means that was the term which made this in the 0 by 0 form, which we have now deleted. Now just see whether the denominator is giving you 0, no. So the numerator, we can just see whether you are having a valid answer or not. Now replacing, now the terms are like this, x square plus 9 into x plus 3 divided by 2x plus 1. Replacing with 3, the value of x will give you 3 square plus 9 into 3 plus 3 divided by 2 into 3 plus 1, which is 9 plus 9 18 into 3 plus 3 6 divided by 6 plus 1 7. 18 into 6 will give you 108. So 108 by 7 is your final answer. Okay. Ninth problem is limit x tends to 0, ax plus b divided by cx plus 1. Now in this problem, again when we replace x with 0, you can just see that the denominator is not giving you 0. Now again the numerator will also not give you 0. So this is not in the form 0 by 0. That means you can apply the direct method, that is just replacing the value of x with 0. And that is enough. You will get b by 1, which is b. Okay. Now for question number 10, which is limit z tends to 1, z raised to 1 by 3 minus 1 divided by z raised to 1 by 6 minus 1. When you substitute z as 1, you will get 1 minus 1 by 1 minus 1, which is of 0 by 0 form. So this is of the form 0 by 0. That means you have to do something else other than the direct method. And here, since you have the power of a variable, you can just think of limit x tends to a, x raised to n minus a raised to n divided by x minus a, which is equal to n a raised to n minus 1. Now how to apply this result in this question? Okay, that is the main thing. So you have two methods to approach the same problem. One method is, since this power can be either an integer or a rational number, for both the things you can apply this result. One method is to make the denominator of this term, that is if you have x raised to n minus a raised to n, the denominator should be x minus 1, x minus a. So here again if you see, your x term is z raised to 1 by 3. So x is z, power is 1 by 3. 1 can be again written as raised to 1 by 3. So the denominator which you should get by comparison with this is z minus 1. Again when you move on to this one, here also the power is 1 by 6 and instead of x you have z. That means again it has the denominator as z minus 1, then you can apply the result. So the easiest thing is to multiply, or you can say the divide both the numerator and denominator with z minus 1. You can apply the result. I can write 1 as 1 raised to 1 by 3. Now I am dividing z minus 1 for this numerator. Again for the denominator I am giving the same term, which is z minus 1. So you can just see that the question has not been changed, because z minus 1 will get cancelled and you will get the same answer. Okay, but the thing is now you can apply the result separately. Again, limit of a fraction is equal to fraction of a limit. So you can just apply the limit to both the things. Again z tends to 1, it is appropriate, correct with respect to that formula. So you can apply in the numerator like this, divided by in the denominator also. Okay, what will be the answer then? Limit z tends to 1 of this will give you n, which is 1 by 3 here, into a 1 the whole raised to 1 by 3 minus 1 divided by, for this if we apply you will get instead of n you have 1 by 6 into 1 raised to 1 by 6 minus 1. Now whatever be the power of 1, you can just cancel them, it will be 1 again. So you will have 1 by 3 by 1 by 6 only, that is 6 by 3, or the answer is 2. So this is one way to approach the problem. Now I will tell you another way to approach the same problem. Now again for the same problem, if I am writing the numerator as the whole square of this term can be written as the whole square of something, that means 1 by 6 the whole square. 1 by 6 the whole square will give you, see, if you have z raised to 1 by 3, if I am writing z raised to 1 by 3 as z raised to 1 by 6 the whole square, then it will give you z raised to 2 by 6, which is z raised to 1 by 3. That means I can write z raised to 1 by 3 as z raised to 1 by 6 the whole square. Okay, so limit z tends to 1, z raised to 1 by 3 is replaced as z raised to 1 by 6 the whole square, minus, again 1 can be written as 1 square, divided by the same thing, z raised to 1 by 6 minus 1. Now this is in the form a square minus b square, so that you can write it as a plus b, z raised to 1 by 6 plus 1 into z raised to 1 by 6 minus 1 divided by z raised to 1 by 6 minus 1. That means now you can cancel these two terms and you will get the limit z tends to 1, z raised to 1 by 6 plus 1, replacing z with 1, you will get 1 raised to 1 by 6, which is 1 plus 1, 2. So the answer is not varying, you will get the same answer even if you approach like this. So which one is easy, you can follow. Question number 11 is limit x tends to 1, ax square plus bx plus c divided by cx square plus bx plus a, where a plus b plus c is not equal to 0. Now why this condition is given in this question is, when you replace this value of x with 1, you will get the denominator as c into 1 square plus b into 1 plus a, which is c plus b plus a, or a plus b plus c. So that should not be equal to 0. That is not equal to 0 they are giving. Now if this is not equal to 0, we will check the numerator, that will also be not equal to 0. That means it is not in the form 0 by 0. Right? For confirming that it is not in the form 0 by 0, they have given this condition, because we don't know the values of a, b, c. Now again, for that problem we can just directly apply, that means it can be used as a direct method where we replace x with 1, b into 1 plus c divided by c into 1 square plus b into 1 plus a. So you are getting a plus b plus c by c plus b plus a, which is same as a plus b plus c by a plus b plus c. That means you are getting it to be 1. Question number 12 is limit x tends to minus 2, 1 by x plus 1 by 2 whole divided by x plus 2. First of all, we will just simplify this, that is limit x tends to minus 2, take the LCM for the numerator, you will get 2x and numerator will become 2 plus x whole divided by x plus 2, which is equal to limit x tends to minus 2. This will give you here 2 plus x or x plus 2 divided by 2x into x plus 2, that is these two get cancelled, limit x tends to minus 2, 1 by 2x. Now you can just replace x with minus 2 because the denominator is not giving you 0 there, so that this is 1 by 2 into minus 2, which is minus 1 by 4. Okay.